The life of a star is one of the most powerful and poetic cycles in the universe. A story that begins with clouds of gas and dust and ends in cosmic fireworks or silent collapse. It's a journey that spans millions to billions of years, shaping galaxies and even the very elements that make up life on Earth. It all begins inside a vast stellar nursery called a nebula. These enormous clouds of hydrogen, helium, and cosmic dust float silently in space until gravity starts its work. Slowly, invisible forces pull the gas and dust together, forming dense clumps called protostars. As these clumps grow larger, pressure and temperature at their cores rise dramatically. When the core becomes hot enough, reaching around 10 million degrees Celsius, hydrogen nuclei begin fusing into helium. A star is born. This stage marks the beginning of a star's main sequence life. For most of its existence, the star stays in this stable phase, balancing two opposing forces, the inward pull of gravity and the outward push of energy from nuclear fusion. For a small star like our Sun, this peaceful balance can last around 10 billion years. The star shines steadily, converting hydrogen into helium and emitting light and heat that may nurture planets in orbit. But hydrogen is a finite fuel. When it begins to run out, the delicate balance breaks. The core starts to contract under gravity, while the outer layers expand dramatically. The star swells into a red giant, glowing with a deep orange hue. In medium-sized stars like the Sun, this transformation is beautiful, but brief. The outer layers drift away into space, forming glowing shells of gas, known as planetary nebulae. What remains at the center is a small, incredibly dense core, a white dwarf, the slowly cooling ember of what was once a vibrant star. For massive stars, the ending is much more dramatic. These giants burn through their fuel at a furious rate, producing heavier elements like carbon, oxygen, and iron in their cores. Once fusion can no longer continue, gravity takes complete control, crushing the core inward in a violent collapse. In a fraction of a second, the star explodes in a spectacular supernova, one of the most energetic events in the cosmos. The explosion releases more energy than our Sun will in its entire lifetime and scatters the star's enriched elements across space, seeding the next generation of stars and planets. What remains after a supernova depends on how massive the original star was. If the leftover core has a mass between about 1.4 and 3 times that of the Sun, it compresses into a neutron star, a city-sized object so dense that a teaspoon of its material would weigh billions of tons. If the remnant is even heavier, gravity wins completely, crushing it beyond the point of no return. A black hole is born, an invisible region in space where gravity is so intense that not even light can escape. From the peaceful birth within a nebula to a titanic death as a supernova or black hole, the life cycle of a star is a timeless cosmic rhythm. It's a reminder that destruction and creation in the universe are deeply connected, that every element in our bodies was once forged in the heart of a dying star. In a way, when we gaze at the stars, we're looking back at our own origins, at the cosmic past that made life possible.